We are going to learn how to calculate the mean for a distribution using the assumed mean method. Normally, the assumed mean method is used to find the mean of a grouped data, that of a grouped data and an ungrouped data. So now let's talk about the assumed mean. Given that the mean for a distribution is assumed to be A, so we say that A is the assumed mean. And the difference between the class midpoints for each class interval and the assumed mean is what we call the deviation. So D equals X, which is the class midpoint, minus the assumed mean. Then the mean or the actual mean for the distribution is given by the assumed mean plus sum of FD divided by sum of F. So this is the formula for finding the mean or the actual mean using the assumed mean method. So first of all, let's consider the case of an ungrouped data. So for question number 1, the table below shows the weight of men in an abattoir. Now, using an assumed mean of 56, find the mean or the actual mean. So from the table, we have the weight of men, and we also have the frequency, that is the number of times that a particular weight repeated itself. Now let's rewrite the formula for the mean. So we say that X bar is equal to the assumed mean plus summation of FD divided by summation of F. Now from the question, we have the assumed mean to be 56. We don't know summation of FD, and then we don't also know the summation of F. So we need to find the two. Now from this column, we can find the summation of F. So summation of F means that we want to add up all the frequency values. So let's do that. Now 15 plus 20 is 35. 35 plus 25 is 60. 60 plus 30 is 90. And then 90 plus 10 is 100. So we have the sum of F, or the sum of frequency, to be 100. Now let's find the sum of FD. Now to find the sum of FD, we need F and then the D values. We have the F values, so let's find the D values. Now from the formula, we know that the deviation, which is D, is equal to the class midpoint, that is the X value, minus the assumed mean. So let's create another column for D. So D is the deviation, and that is X minus E. So in finding the deviation, we have the first X value to be 50. So 50 minus 56 is a negative 6. 54 minus 56 is a negative 2. 62 minus 56 is 6. 65 minus 56 is 9. And then 72 minus 56 is 16. So now we've been able to find the D values. So we need to find FD. So we are going to create another column for the FD values. So FD basically means that we are going to multiply the F values by the D values. So 15 times negative 6 is negative 90. 20 times negative 2 is negative 40. 25 times 6 is 150. 30 times 9 is 270, and then 10 times 16 is 160. Now we can add up all the FD values to get the summation of FD. Now negative 90 plus negative 40 plus 150 plus 270 plus 160 gives 450. So we have summation of FD to be 450. Now since we have summation of FD and then we know the value of summation of F, we can plug these two values into this equation to find the mean or the actual mean for the distribution. So let's do that. So X bar equals A is 56 plus summation of FD is 450 divided by 100 for summation of F. So this is equal to 56 plus, now 450 divided by 100 is 4.5. So we have X bar, the actual mean, to be 56 plus 4.5 is 60.5. So this is the actual mean for this data, for this distribution. So this is how to find the mean of a data using the assumed mean method. Now this was an ungrouped data, and so we are going to solve the next question on a grouped data. So for the second question, we have a grouped data. The table below shows the distribution of marks obtained by 30 students in a class. Find the mean using the assumed mean method, given that the assumed mean is 75.5. So in this table, we have the marks or the mark interval, and then we also have the frequency, so the number of times that a mark or marks from a particular interval occurred. So let's say between 41 and 50 we had one occurrence, between 71 and 80 we have 10 occurrences, and then between 91 and 100 we have 3 occurrences. So straight away, let's find the sum of frequency. Obviously, we know that the data shows the distribution of marks obtained by 30 students in a class. So the sum of frequency is going to be 30. Now let's write down the formula for the mean. So we know that the mean is equal to the assumed mean plus the summation of FD divided by the sum of F. Now we know the sum of F, we know the assumed mean, we need to find the sum of FD. Now we also know that the D, which is the deviation, is equal to the class midpoint minus the assumed mean. Now for this grouped data, we don't have the X values, so we need to find the X values, that is the class midpoint. So we are going to create another column for the class midpoint. So to find the class midpoint, we are going to add the lower limits and the upper limits of the class interval, and then we divide by 2. So basically it is 41 plus 50 divided by 2, and that gives 45.5. Now 51 plus 60 divided by 2 gives 55.5. 61 plus 70 divided by 2 gives 65.5. Now we can just add 10 to the previous value. So 75.5, 85.5, and then 95.5. So these are the X values or the midpoint values. Now let's find the deviation. So for the deviation, we are going to subtract the assumed mean from the class midpoint. So for the first one, we have 45.5 minus 75.5, that is negative 30. 55.5 minus 75.5 is negative 20. 65.5 minus 75.5 is negative 10. 75.5 minus 75.5 is 0. 85.5 minus 75.5 is 10. And then 95.5 minus 75.5 is 20. So we are done with the deviation. Now let's find FD. So for FD, we are going to multiply the frequency values by the deviation. So we have 1 times negative 30, that is negative 30. 5 times negative 20 is negative 100. 7 times negative 10 is negative 70. 10 times 0 is 0. 4 times 10 is 40. And then 3 times 20 is 60. So to find the sum of FD, we are going to add up all these values. So negative 30 plus negative 100 plus negative 70 plus 0 plus 40 plus 60 gives negative 100. So to find the mean, we are going to substitute summation of FD, summation of F, and then the assumed mean into this equation. So we have X bar equals A is 75.5 plus summation of FD, that is negative 100, divided by summation of F, that is 30. So this becomes 75.5 plus negative 3.3333. So 75.5 plus negative 3.3333 gives 72.1667. So the mean is 72.17. So this is the actual mean for this data. Now sometimes you'll be asked to find the mean of a distribution or the mean of a data using the assumed mean method without a question giving you the assumed mean. Now in this case, you are supposed to guess an appropriate assumed mean, in the sense that the mean itself is the measure of central tendency. So the mean itself, that is X bar, will try to locate the midpoint of the data. So in guessing the assumed mean, you need to try and guess a value close to the midpoint of the data so that the deviation from the mean wouldn't be too much. So whenever you encounter that situation, try as much as possible to guess a mean that is close to the midpoint of the data so that the deviation from the actual mean will not be that much. However, the value of the assumed mean does not affect the actual mean, just that it would be more appropriate to choose an assumed mean value closer to the midpoint of the data.